Hey man, in community, I wanted to show this project. I need some advice on improving this as well. So it's basically an idea to video generated using Manim. And let's say the idea was given to him, and I'll show that
Sure.
demonstration as well. But let's just see this first.
Meet Bernhard Riemann, a brilliant German mathematician. He is known for the famous Riemann hypothesis. It involves the zeta function, a cornerstone of number theory. Another important contribution of Riemann is his idea of Riemann sums. These sums help in approximating the area under a curve.
So this is a pretty good demonstration. I'll probably add something. Okay, let's say binary search, and let it generate while I talk about how I made it work and why I need help. So a year ago, I started learning Mana, and I kind of, because I wanted to, I used Obsidian and I stored a hell lot of notes, and I just, okay, I'm not sure why the depth is not going over there. It's my keyboard. That is quite unfortunate. But yes, so I kind of learned it in this manner where like, I started with Manim, common function, building blocks, general animation, metric size, matrices in Manim, basis transformation, coordinate systems, and I kind of understood. So I have a query-based system on all of this. This mostly generates arrows and matrices and numbers and latex and all those stuff, and not on the 3D. I have specifically mentioned to not generate 3D. So because a lot of these things are deprecated, some of the times I get the deprecation error that this method and this attribute has been removed in Manim 0.19. I'm not sure if we have enough data. And I also wanted to get more data so that I could potentially train a model instead of querying it or asking it to do something with a system prompt. So this basically uses a TTS model to generate the audio, an LLM to generate somewhat of a code using the system, and just merge them using FFmpeg, and we have a video, which is pretty great because it's pretty useful. I mean, it hallucinates a lot, but it's decent to watch. So let's just watch this.
Binary search, efficiently find a target in a sorted array. Visualizing a sorted array. Highlighting the element we are searching for. Binary search uses left and right pointers. Move the right pointer to the middle. The target is on the right. Let's adjust the left pointer. Left and right pointers meet. Final matrix representation of the algorithm.
I don't know why it said the metrics because I have some example codes and it uses matrices, so it kind of generates matrices. But I think it's pretty cool. So I wanted more data. I want man and community to engage with it. I'll soon deploy it so that you guys can use it. But before deploying, I want somewhat of a data, probably categorized data that I could look for and search for something like Riemann integrals and slope. So here this is a categorized data. I can feed this and have multiple Riemann. So the next time someone gives an input of Riemann, it would be able to understand that, oh, we're talking about Riemann. Let's say I give something like number theory concepts. Okay, just I cannot think of anything right now. Let's just do Hilbert transform because I think it's a pretty difficult concept to visualize. I'm not sure it would do a great job as well. But so if we could have somewhat of a categorized data, I'm ready to build this open source. I will open source this eventually. Currently, I'm just going to keep testing it locally so that it does not break, especially when I upload it to Streamlit. Because in a public cloud, you would much rather have a safer service than something that breaks. For example, because I mean, I am using Gemini's API, and it's not that compute intensive. The TTS model and everything combined just runs on 1 GB. But if I have, let's say, a 7 or a 13 billion parameter model, add 4 or 5 to 6 gigs of VRAM extra, but we have our own fine-tuned model which works better than this probably. And that is the whole idea. I'll just show this as well.
The Hilbert transform. It takes a function as input and outputs its Hilbert transform. The transform convolves the function with 1 over pi times t. Mathematically, the Hilbert transform is given by this integral. Visually, it can be seen as a rotation, represented by this matrix, the result of transformation. It has many applications, especially in signal processing.
I'm not sure if the rotation part is correct. It's supposed to just delay the signal by 90-degree phase, but it's what I said. It takes around matrices because I have given that as an example code and it's there. So I want to improve on this and I want a feedback from you guys on what I could do better and probably learn from it and also potentially get more data and how to find that data. So this was the inspiration. This was 1 year ago. This is 1 year. 1 year ago, I tried to learn Manim myself, and after 1 year, I'm trying to make an AI learn Manim. It's a pretty good library. Hey, what can I say? Thank you for watching this.